Have you ever stood on a stage before? If so, have you shouted anything or played an instrument while you were on it? If you have, then you've probably experienced what I did during my concert just now. When I'm on the stage playing my violin, it sounds way louder than it does when I'm playing in my room. And that's not coincidence, that's engineering. I'm Annika, a second-year student studying creative technology and design at CU Boulder. Listen closely, because today we're going to talk about some of the basic things you have to know when you're an acoustical engineer. Acoustical engineers are all about sound. They aren't the same as audio engineers. Audio engineers work behind the scenes on live performances, using things like microphones, speakers, and amplifiers to make the best sound possible for the audience. Acoustical engineers, on the other hand, build structures and devices to manipulate sound. They design giant concert halls in order to make sure as many people as possible can hear a symphony concert. They design things like speakers for audio engineers to use. Anything that manipulates sound, making it louder, clearer, softer, comes from an acoustical engineer. And in order to manipulate sound, acoustical engineers have to understand what sound is and how it acts. And to understand it ourselves, let's start with the simplest question. What is sound? Sound is a movement of energy, like light. It can actually do work, which means it can transfer energy to something else and cause it to be displaced. Have you ever seen someone break glass by singing? That's an example of sound doing work. Sound is produced by vibrations, objects or molecules rapidly moving back and forth. When a vibration starts, so does a sound. When the vibration stops, sound stops. Think about hitting a cymbal with a drumstick. When the stick makes contact with the cymbal starts vibrating, and we hear a sound. The cymbal keeps vibrating for a little longer, and the sound fades as the vibration slows down, until both of them stop. But how do we hear the sound from the cymbal? Well, sound travels in waves. When you throw a rock into a pool of water, you see ripples in the water around it, almost like the ripples came from the rock itself. Sound travels kind of like those ripples, in invisible waves coming from the source of the vibration through the air. And when those waves hit your ear, you hear a sound. We can even draw these waves using something called a waveform. The amplitude of the wave, or how tall it is from its midpoint, tells us how loud a sound wave is, where the taller it gets, the louder it gets. The wavelength, or how much space there is between the start of one wave and the start of the next, tells us how high or low-pitched the sound is. The bigger the wavelength, the lower pitched the sound is. Much like you can't have ripples in water without having the water for the ripples to travel through, sound needs some sort of medium to travel through. And this medium can be any sort of material, whether it be solid, liquid, or gas. And this is the part acoustical engineers are really interested in, because sound doesn't travel through all materials in the exact same way. When a sound wave hits a material, three things can happen. First, the sound wave can be absorbed, where the material takes in the sound, kind of like a sponge takes in water. This causes the sound to become quieter. Soft materials like carpet and foam absorb sound, which is why sound panels are usually made of soft materials. Second, the sound wave can be reflected, where the wave bounces off the material. This is what causes echoes. Hard, non-porous materials like metal, concrete, and glass tend to reflect sound. And finally, the sound wave can be transmitted, where it just goes straight through the material. Air is the most common transmissive material. Materials can also cause a combination of all three things to happen. Acoustical engineers measure sound with decibels, which is a measure of how loud a sound is. The softest sounds a human can hear are 0 decibels, while the loudest sounds we can safely hear without any ear protection are around 85 decibels. By measuring the decibel of a sound after it has moved through a material, acoustical engineers can determine whether that material absorbed, reflected, or transmitted the sound. And then, once they know how sound interacts with a material, they can use those materials to manipulate sounds. And thus, we get spaces like this concert hall, where carefully placed absorbent and reflective surfaces ensure the sound from the stage reaches every seat in the audience, without losing any energy by going places it doesn't need to. Thanks to acoustical engineers, we get to experience sound in ways we never could have without them, and now you know the basics of acoustical engineering. Check out the full lesson on TeachEngineering, then use what you learned in the associated activities, what soundproofing material works best, and design a soundproof room.